This video will try to implement the Bitonic sequence DSA problem. Now, Bitonic sequence is kind of a moderate to a bit difficult level DSA, you can say, but it is not that difficult once you understand the overall problem statement. Uh, you usually get a quite a lot of like text to read and everything. A lot of time gets devoted just to understand what this whole text is trying to communicate. Uh, but majorly, if you will focus on the input, what this is trying to do, this is trying to create a mountain like curve or mountain like graph, right? So Bitonic sequence is a combination of incrementing and the decrementing sequence. So over here, uh, there was 10, then there was 8, so it created a mountain. Like there was some incrementing sequence, there was some decrementing sequence, then again there was a incrementing sequence, so this created a split kind of a thing. So up until this particular phase, this got inserted as one of the subpart of the Bitonic sequence. Then we move further, and here from here on, you can see the sequence is getting increased. From 8 it reached 9, from 9 it reached 12, from 12 it reached 15. This was the peak of this mountain. Then there was a drop, and this is permissible in Bitonic sequence, as this is the combination of incrementing plus decrementing. So till 6 it was still a Bitonic sequence, but again when we reached 7, again it drifted, it got lifted, and that created a rift. So till this there is one Bitonic sequence, and till here there is this one Bitonic sequence. So through this problem statement we need to find out the maximum Bitonic sequence, maximum element of a Bitonic sequence that exists from this input list. All right, so we begin. We can create a function, generate Bitonic sequence, and this will accept the input list. All right, so for this what we need a stack, we need the resultant list, and in case if I come across any other thing that we may need, I'll describe it while implementing it. So our strategy would remain, we need to have the index pointer also. So for idx comma, let's call this as plim whatever in enumerate input list, right? Yes, we need to have p set. This will act as the processing set for us, right? And we avoid, if at all this index was already processed, and this will make sense once I write that code later. So for the time being, just consider we are ignoring already the index that we have processed. If index in p set, we simply continue this iteration, right? Now what we need to do, we need to check if stack and p element, let's call this as current element, and current element is greater than or equal to stack of -1, right? So like for example, in the first iteration there will be nothing, so else condition will get executed. But let's suppose that first stack has this 10 as the first most element, or let's consider the stack has the 8 as the first element, right? Now the next element is 9, and this condition is met for 8 and 9. Stack has one element, and the current element, that is the 9, is greater than or equal to the latest element that was inserted into the stack. So we keep on appending this, and this will mark as the incrementing sequence, right? So here we pass current element. In the else case, also we should pass on the p set, basically acting as the processor in the IDs. We move on to the else case. So as soon as we encounter the else case, let's consider this 8, 9, 12, 15 sequence only. So until 15 we kept on appending the element in the stack list. But as soon as we got 6, the else condition got triggered. So this is also a permissible Bitonic sequence for us. Even the 6 needs to get inserted. So uh, we will do stack dot append current element. We will append the pset to the current idx, right? Now what we need to do, we now need to check all the rest of the element is again a Bitonic sequence, like they are in the decrementing order only, or they are again getting increased. As in this case, this is getting increased, right? So we can ignore up and until the element that was already processed. So we create an inner list. Inner list is equal to input list of idx plus 1. Basically till idx we have already reached the 6, for instance the example that we were seeing. So we are mostly interested in the next most element, right? And let's call this as c index. So this is kind of like a counter index which is the idx for us. Okay, so we iterate now in ival as for ival in inner list, right? If ival is less than or equal to, so earlier we were checking greater than or equal to, now we will check less than or equal to decrementing sequence. Stack of minus 1, whatever the latest element was inserted. If this is true, then what we need to do, we need to increment the counter by 1, right? We need to add in the process set pset dot add idx c idx. Now this is already inserted. We also need to append it into the stack dot append ival. This is done. If this condition is not met, as in this case this condition is not met, so we trigger the else part and we directly break it. So up and until now whatever element that we have in the stack, uh, we can directly append into the resultant list. So inside resultant list we put the stack, right? Now we need to reset our stack reset will happen in the order of, in the manner of input list of this counter index, because this counter index has the actual value for which the latest element needs to get inserted. I believe that is about it for the Bitonic sequence. If I am forgetting anything, I'll correct this. But majorly, all of the logic is done. So we put input list is equal to this. Input list, and we execute solution.py. Something is missing for val in inner list. Yes. So here we need to have the slicing index. Also, I haven't returned the result list, so that also needs to get returned. Let me now check. Int object is not subscriptable. Uh, what have I missed? And it's fairly okay. Even when you are doing any interview session, it is expected from you that you will be doing this mistake and you will be seeing a lot of error. What interviewer will mostly focus upon that how you are trying to adapt to the situation, whether you are panicking or not, and what is your next go-to step, how are you dealing with this particular thing, right? Solving the dsa is one part of the problem, but your mindset and how you are dealing with the thing is another. So here I actually need to wrap it in inside a list, not a complete thing. Earlier this was getting destructured as just that list, right? Okay, so yeah, this is one of the edge case that we also need to solve. So when we reach the last most iteration, in the else condition will never get triggered, because after this sequence there was no sequence that could have triggered the else condition. So if you will check the stack, it will have the last sequence that you want. So after completing all of your pass, you should do if stack and stack not in result list. You should ideally append result list dot append stack, and that's about it. This is how the whole thing is happening. A quick rebrief. Bitonic sequence is the combination of incrementing and decrementing sequences. It creates a mountain-like curve. The keyword here to remember is the mountain-like curve. Right? Do not spend much of the time in like reading all of this text. This will save you a lot of time actually. So the whole logic remains same. We utilize the stack data structure. We have result list to obtain an output are the end goal. Preset we use to avoid the duplication and to avoid all the indexes that is already processed. uh, if we have any element in the stack and the latest element that we are current element or the latest element that we are trying to process is greater than or equal to latest element in the stack, we append it to stack and we append its index to the process set, right? In the else part, the else part is also permissible because it is the combination of incrementing plus decrementing. So the very most else part will be indicating this particular condition. After 15 we got 6, so this is what is happening over here, right? Then we are mostly interested in the follow up elements. So we avoid this index and we treat or we take into consideration all of the element after this 6, after this 6 for this particular example, right? Then we again loop through it and we check for the decrementing sequence. If at all the condition was meeting, the counter index would have incremented, we would have appended it to the process set and we would have appended it to the stack. In our particular use case, this was not happening. The else part got triggered, it got break. Whatever element that we had in the stack we have appended into the resultant list, and we put the reset condition as stack as input list of CIDX, because CIDX holds the value uh, for which you need to again start from where you want to start ideally, right? You do not want to start from 7, you want to start from the 6 in this particular case. And as a part of an edge case, there may come a sequence wherein now this wouldn't have happened if the sequence would be 6 comma 5, right? Then we wouldn't need this edge case part, but in this particular case, this after this decrement there is again an increment, and we in our current code base there is no logic to address this. So uh, we can simply address this by using this if condition code block. So you check if there is any element in the stack and the current combination is not inside the resultant list, you again append to the resultant list, and that's how you can finally get the final sequence also. I hope this thing was useful for you. Thank you so much.